Good morning. This is your Stat Sensei, Mr. Spensei, and this is going to help understand whether it's a geometric or binomial distribution. A lot of times I have students that struggle to determine which is which, but those that follow these general steps tend to do pretty well with it. So first off, please remember both are Bernoulli distributions, both geometric and binomial. Both are binary. In other words, they have a success or failure. Probability of success is independent, and the probability doesn't change for each trial. This is the same for all, but for both of them. What's different? The binomial has a fixed number of trials. We know how many trials we're going to have, and we're going to track the number of successes. And it's possible to have 0 successes. The geometric doesn't have a fixed number of trials. It's continue until the first success, which means it could never happen. All right, there may never meet that first honest guy. And instead of starting at 0, we will always start at 1. Okay, so the binomial has a fixed or predetermined number of trials or fixed group size. Geometric continues until we have the first success. Binomial asks for the probability of a certain number of successes for a given number of trials or a given group size. Geometric asks for the probability the first success occurs within a specific time period. So let's just try to recognize this. All right. Assume that 13% of the population is left-handed and that we only selected 15. Circle the correct distribution. The first lefty is the fifth person. Oh, we're talking about the first, and we don't have a group size. This makes this a geometric. The first lefty is the second or third. Once again, we don't have a group size, so it can't be a binomial because we don't have a group of trials, but this will be the second or third. So this is going to be a geometric, but it'll be a geometric that requires a summation because we have multiple values. This one would just be a PDF. All right. There are exactly 3 lefties in the group. Oh, wait a second. We have a group. We have a group. All of a sudden, it's a binomial. And because it's exactly 3, this will actually be a binomial PDF. There are at least 3 lefties in a group. Well, if I had my number line and I made it out, it'd go, oh, it could be 0, 1, 2, 3, 4, dot, 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 all the way to 15. We have a group. That makes it a binomial. We have multiple values. This makes it a summation. All right, so this will be a binomial with a summation. There are no more than 3 lefties in a group. Well, again, 0, 1, 2, 3, 4, dot, 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 all the way to 15, no more than 3. I have a group. By the way, this is from the group, so this makes it a binomial. And because I have multiple values, this will be a summation. Out of the 15 people, oh, this tells me I have a group. How many lefties do you expect? All right, so this is an expected value. So this is going to be the binomial, but the binomial expected value, which means we're going to have to use the formula expected value equals NP. What's the probability that the majority is right-handed? Well, that means that I'm going to have to sit there and go, well, I could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to 15. And if these are left-handed, this would be what I would be working with, and I'd be working with a group. So this makes it a binomial. All right. And because I could have 0, 1, 2, or 3 multiple values, this is going to be a summation. How many people must be surveyed until a lefty is selected? This is like saying until the first lefty occurs. So the fact that we're talking about a first makes this a geometric, but in this case, until a lefty is, how many must be surveyed? We're looking for the count. So this is an expected value. We expect to survey this many, 1 over P. So we have to use that formula, 1 over 0.13 in this case. All right. The next one, the number of lefties among 15 people. All right, so we have a group. We have a group of 15. This makes it a binomial. They're actually asking for how many. If it's how many, I'm looking for the expected value, which is NP. All right. Now, in this case, whenever we had an N, the value was 15. Whenever we had a P, it was 0.15. And technically, we could have calculated those probabilities, but we'll hold off on that. Well, this was a short video. I hope it was helpful. I hope you can tell the difference between a geometric and uh, a binomial. The main thing is a geometric continues until the first success. In a binomial, we have a specific number of trials or we have a specific group size that we're selecting from. All right. Appreciate you watching. Hope to see you on the next one. Thank you.